Complex number. We are discussing about polar form of complex number. Polar form of complex number. Cartesian form and polar form. That's polar form we are discussing. Uh, Let me draw a figure. Suppose this is x dash o y dash. This is Cartesian plane in a point x comma y. This is y, this is x, this is theta. This is complex plane. Then in complex plane, z equal x plus iy, that is the complex number standard form, can be represented by a point. Complex number z x comma iy can be represented by a point P with Cartesian coordinates x comma y. Let theta be the angle. Standard position with OP. Standard position with OP as its terminal arm and are the length of OP. This is R. OP is R. Then in polar form, we can write z equal r cos theta plus I r sin theta. But before writing this, or r z equal in polar form z equal r cos theta plus I sin theta, or r is common, cos theta plus I sin theta, we can write where this is the pattern or the form of the polar form of the complex number. Here you can see from the given figure itself what is the value of cos theta. First we have to find how did we get this. Cos theta is base by hypotenuse, base by hypotenuse, then is x by r, and by the cross multiplication, what is the value of x? X is r cos theta, and x is r cos theta. Similarly, sin theta, what is the value of sin theta? Perpendicular by hypotenuse, y by r. Therefore, y equal r sin theta. And the standard form of complex number is x plus iy, and the value of x is r cos theta plus value of y is r sin theta. Then while taking r cos theta plus I sin theta, This is the polar form of the complex number which is mentioned here. And next part is what is R? How to find R? You may have a question. By Pythagoras theorem, h square equal p square plus b square. In that sense also, R is x square plus y square. And what is tan theta? You can find tan theta is y over x, where ex does not equal to 0. So you can find R is root under x square plus y square from this relation also. Tan theta is y by x, that is understood. X does not belongs to 0. In this way we can find the standard form of polar form in the complex plane, that is z equal r cos theta plus ir sin theta. Then we have to continue about, we know R is the mode of Z, modulus of Z, and theta is called the amplitude or argument, argument, argument of Z, and it is simply written as AMPZ or ARZZ, that is theta. You have to understand this is amplitude or argument is Z. Now moving to the next part, general form of complex number. General form of complex number. General form of complex number. In this case, Z equal R cos theta plus 2n pi plus I sin theta plus 2n pi, where theta is in radian, or Z equal R times cos theta plus n times 360 degree plus I sin theta plus n 360 degree, where theta is in degree, n is in integer, n is in integers, as sin theta and cos theta both are periodic with a period 2 pi or 360 degree. This is discussed in grade 11 also. So this is the general form. In polar form we use theta plus 2n pi. That means after 360 degree that the sine curve will repeats, or the same position will repeats. That's why that is periodic in 2 pi. So theta plus 2n pi and theta plus 2n pi we have, if theta is in radian and in degree, we can use, instead of 2 pi we can use 360 degree. This is the general form of complex number. Now next part we have to move, that is Euler's formula. That is very important part of the lesson. That is Euler's formula. Euler's formula. Euler's formula. About Euler's formula, that is the relationship we are discussing under the complex number system. In this system we are discussing Euler's formula. There are many Euler's formula, but under the complex number system we are discussing or dealing the relationship the relationship between the complex number in the exponential form and trigonometrical form. Trigonometrical form is known as Euler's formula in the complex number. Then it is defined as ei theta equal cos theta plus I sin theta. Then ei theta is cos theta plus I theta. Now we can simply observe that what is z? Z is r cos theta plus I sin theta. Now it becomes r itself r cos theta plus I sin theta is ei theta. So what is z? Z is r times ei theta. We can find this. Now it has several applications in physics and engineering. It has several applications in physics and engineering. It has several applications in physics and engineering. Now for theta equal 0, ei0 equal what? Cos 0 plus I sin 0. Cos 0 is 1, sin 0 is 0, it will be 1. Similarly, if theta equal 2 pi, then ei 2 pi equal cos 2 pi plus I sin 2 pi equals simply 1 value. And e to the power I pi plus 1 equal to 0 is called Euler's identity. So in this way we have discussed some more about Euler's polar form of complex number and Euler's formula under the complex number system. Now problem number 1. Instruction is express the following in polar form and Euler's form. Okay, now problem number 1. Or example number 1, that is 2 plus 2y. Okay, this is instruction number 1. This is problem number 1. We have given 2 plus 2y, then we have to express in polar form, then Euler's form. So the solution for this, firstly let 2 plus 2i equal r cos theta plus I sin theta in polar form, or r cos theta plus I r sin theta, and then by the definition of the equality of to complex number what is r cos theta? That is 2 r cos theta equal to, and from here you can find x. This implies x equal to 2, and r sin theta equal also 2. That implies y equal to 2, x and y, because x is r cos theta and y is r sin theta. That's why their value is 2, we can find. And we know r equal root under x and y are known. X square plus y square equal 2 square plus 2 square under root equal root under 8. That is 2 root 2. We find value of r equal to 2 root 2. And again tan theta equal y over x equal tan theta is y over x. What is y? Y is 2. 2 by 2 is 1. Therefore theta equal 45 degree or pi by 4. Yes. Now the given problem or question in polar form, that is 2 plus 2i equal, what is the value of r? R is 2 root 2 times cos theta is cos 45 degree plus I sin 45 degree, or we can write in radian form, equal 2 root 2 times cos pi by 4 plus I sin pi by 4. This is the polar form. And then again in Euler's form, we can express in Euler's form. From here 2 root 2 times cos pi by 4 plus I sin pi by 4 equal r, 2 root 2 is r, e to the power I pi by 4. In this way we can express in Euler's form as well. So the same questions we have changed into polar form and in the Euler's form. And again problem number 2, let's move. The problem number 2 is just instruction is same, just we have given 2i. Now we can find the solution. Let 0 plus 2i equal r cos theta plus I r sin theta. Then what is x? X is r cos theta, that means 0 equal r cos theta, therefore x equal 0. Y equal r sin theta, that means y is 2 equal r sin theta, therefore y equal to 2. We obtain x equal to 0 and y equal to 2. Now r equal root under x square plus y square. To express in both form we need theta and r. That's why x square is 0 square plus 2 is 2 square equal to root under 4 equal to 2. We obtain 2. And tan theta equal y over x equal y is what? 2 by 0. 2 by 0 equal to infinity equal to 90 degree or pi by 2. So after finding this, we can express in polar form. Now in polar form, 2I equal, what is the value of r? 2 cos theta is, directly I have written in radian, 2 pi by 2 plus bracket, we can write I sine pi by 2. This is the polar form of the given question. And in Euler's form, we can express in Euler's form, that is 2I equal, r is 2 times e to the power I pi by 2. Answer. From here you can find theta is pi by 2, I itself I, e is, r is 2. So we can write, after finding this r and theta, you can express in Euler's form, that is 2 dot e to the power pi by 2. This question is also sure. Now moving to the third problem, it is interesting question. Question number 3, or problem number 3. The instruction is same. Then the question is I minus root 3. Now the solution for this question is, firstly let I minus root 3 equal r cos theta plus I r sine theta. Then what is x? X equal to r cos theta. X is what? This is imaginary, this is real. Or minus root 3 equal to r cos theta. Therefore x equal to minus 3. And y equal to r sine theta, or imaginary part, this is simply 1, equal to r sine theta. Therefore y equal to 1. Therefore r equal root under x square plus y square, that is minus root 3 whole square plus 1 square, that is root under 3 plus 1 equal to root under 4 equal to 2. We find r. Now what to find? Again, tan theta equal y over x equal y is 1 over minus root 3 equal, sorry, y is 1, yes, 1 over minus root 3 equal 150 degree. But how? Yes. So dear students, we have to remember here the coordinates here, x and y both positive. Here minus x comma y, here minus x minus y, and here x minus y. In which quadrant we will find the angle? So here, while comparing x and y, if x is negative and y is positive, that should be in the second quadrant. So the angle in second quadrant is tan theta is 150 degree. If both are negative, suppose minus x, suppose minus 3, minus root 3 and minus 1, suppose we obtain this, we will get this and we will get plus root 3, but the angle should be from third quadrant, because both are negative. That gives, in this plane, complex plane, both the coordinates, Cartesian coordinates are negative, means the angle made by from the this initial line to that, by the line, the particular line or moving line is more than 180 degree, or that should be in the third quadrant. So you have to check whether the value of x and y are both positive, x negative, or y negative, or both negative. In that way you can find the theta or value of the angle. So Now in polar form, now in polar form we have to express in polar form, that is I minus root 3 equal, what is the value of r is 2 cos 150 degree plus uh, I 2 sin 150 degree. We can express this 150 degree into pi form, that is 2 cos 5 pi by 6 plus I sin 5 pi by 6 for 150 degree. And in Euler's form, that I minus root 3 equal, r is 2 e I and theta is pi by 5 pi by 6. This is the answer for the question in Euler's form. Now moving to the next problem, that is problem number 4. The instruction is same. The question is 1 plus I over 1 minus I. This is the question. Now the solution is, we have to find the solution. Directly you cannot express, that's why we have to multiply by the conjugate, and we have to rationalize the denominator like that. So 1 plus I by 1 minus I equal 1 plus I by 1 minus I times 1 plus I over 1 plus I. Then the product of these two is 1 plus I whole square over a square minus b square, that is 1 minus I square, and this is 1 plus 2I plus I square over minus y square is 1, that's why 1 plus 1, it is this is 1 plus 2I minus 1 over 2 equal, these two are cancelled, 2I by 2 equal to I, equal to 0 plus I. So we obtain this result. From the given question we can express in this form. Let 0 plus I equal r cos theta plus I r sin theta. Then x equal r cos theta equal, or 0 equal r cos theta, therefore x equal 0, y equal r sin theta, or y is 1 equal r sin theta, that's y is 1, y is 1 and x is 0 we obtain. Now our target is to find the r and theta. Now r equal root under x square plus y square equal root under 0 square plus 1 square equal to 1, and tan theta equal y over x equal 1 over 0 equal to infinity, that's what theta equal to 90 degree in case of tan, or pi by 2. Now in polar form we can express, 1 plus I by 1 minus I equal, r is what, r is 1, so 1, that itself 1, cos pi by 2 plus I sin pi by 2. And in Euler's form, 1 plus I by 1 minus I can be written as 1 dot, that is r is 1, and e to the power I pi by 2, that is Euler's form. In this way we can solve 4 number question. Next question is problem number 5. The instruction is same. The question is under root 1 minus I over 1 plus I, and solution. we have given this also, we have to rationalize 1 plus I equal 1 minus I by 1 plus I times 1 minus I by 1 minus I under root, then under root 1 minus I whole square over 1 minus I square equal root under 1 minus I whole square over 1 plus 1 equal 1 minus I over 2 under root 2, because this is rational, this is the radical sign, that power 2 and the square of that gone, and the denominator root under 2. Then we can separate them, 1 by root 2 minus I by root 2. So let 1 by root 2 minus I 1 by root 2, yes, or plus minus 1 by root 2, yeah, we can express in this also, equal to r cos theta plus I r sin theta. We can suppose this. Then x equal to r cos theta. What is x? 1 by root 2 equal to r cos theta. Therefore x equal to 1 by root 2, and y equal to r sin theta. Minus 1 by root 2 equal r sin theta. Therefore y equal to minus 1 by root 2. Then r equal root under x square plus y square equal root under x square 1 by root 2 whole square plus minus 1 by root 2 whole square. From these two relations, that is 1 by 2 plus 1 by 2 equal 2 by 2 is 1, r is 1, and tan theta equal y over x. Y is minus 1 by root 2 over 1 by root 2 equal to minus 1. As I mentioned you earlier, y is negative in the fourth quadrant, yeah, y is negative, x is positive, that is in fourth quadrant. Therefore theta equal to 315 degree. 360 minus 45 is 315 degree. 350 degree we obtain this. Now 315 degree or 7 pi by 4. Now after obtaining these two parts, you can express in polar form. In polar form, that root under 1 minus I by 1 plus I equal r is 1, so cos 7 pi by 4 plus I sin 7 pi by 4, and in Euler's form, root under 1 minus I by 1 plus I equal r is 1 times e to the power I 7 pi by 4 equal e I 7 pi by 4. Answer. In this way we can the instruction of the question is express the following complex number, express the following complex number in the Euler's form. in the Euler's form. And the question, problem number 6, 3 cos 60 degree plus I sin 60 degree. Solution, we have given 3 cos 60 degree plus I sin 60 degree, or simply we can write a 3 cos pi by 3 plus I sin pi by 3. Degree also we can be written, basically we can express into radian measurement. 3 e I pi by 3. Answer, this is in Euler form. R e I theta. R e I theta. Yes. Now problem number 7. The same instruction. 2 cos minus 45 degree plus I sin minus 45 degree. Solution, we can do this also directly. 2 cos minus 45 degree plus I sin minus 45 degree equal 2 cos minus pi by 4 plus I sin minus pi by 4, simple expression, equal R e I theta. R means 2, e I theta is what? Minus pi by 4. One more step, 2 times e to the power minus I pi by 4 is the answer. Now moving to the next instruction. Moving to the next instruction. Next instruction is simplify using Euler's formula. Problem number 8. Cos 32 degree plus I sin 32 degree times cos 13 degree plus I sin 13 degree. We can we can simplify this using Euler's formula. So here firstly we have given cos 32 degree plus I sin 32 degree, cos 13 degree plus I sin 13 degree. Simply R is 1 here. You can express this 1 times cos 32 degree and I sin 32 degree 1 times cos 13 degree plus I sin 13 degree equal, you can express this we can convert into pi form, but directly also in terms of theta we can write it will be e to the power I theta is 32 degree R e I theta. R means 1 dot e to the power I and theta times 1 times e to the power I 13 degree equal e to the power will be added, that is e to the power I is common 32 plus 13 degree equal e to the power I 45 degree equal e to the power I pi over 4 then pi by 4 is 45 degree. Then we can express again, we can convert in this form, that is 1 itself, cos pi by 4 plus I sin pi by 4 equal cos pi by 4 is 1 by root 2 plus I sin pi by 2 is 4 is also 1 by root 2. This is the answer for this question. Now moving to the next problem. Next problem is problem number 9. We have given cos 80 degree plus I sin 80 degree over cos 20 degree plus I sin 20 degree. So the solution is cos 80 degree plus I sin 80 degree over cos 20 plus I sin 20 degree equal radius is 1, then it can be expressed e I 80 degree over e I 20 degree equal e to the power I 80 minus 20 equal e to the power I 60 degree equal e to the power I pi by 3. Then we can express in this form, that is cos pi by 3 plus I sin pi by 3 equal, this is the 61 by 2 plus sin 60 is I root 3 by 2 is the answer for this solution. Now moving to the next problem. Problem number 10. Problem number 10. Cos 3 theta plus I sin 3 theta times cos theta minus I sin theta whole over cos theta plus I sin theta whole square. Now the solution for this question is, we have given cos 3 theta plus I sin 3 theta times cos theta minus I sin theta whole over cos theta plus I sin theta whole square. Then we can express directly, we can express this e to the power I 3 theta, and here we have to express, we have to manage cos minus theta. Cos minus theta is cos theta, and plus I sin minus theta, because sin minus theta is minus sin theta, then minus and plus, it will be minus, will get the same result. And this is e to the power I theta whole square. Then e to the power I 3 theta times, now you can express this e to the power minus I theta over e to the power to the power can be multiplied I 2 theta. 2 times I theta is 2 I theta. Then we can express e to the power I 2 theta, e to the power I 2 theta equal e to the power I 2 theta minus 2 theta, that is e to the power naught, equal to 1 answer. In this way we can solve these problems using Euler's method.